In this video, we're gonna learn how to solve speed problems, how to draw graphs, and interpret them. Let's imagine there is a car that covers 10 meters in 1 second. We can express it in the following way. Velocity is equal to delta x divided by delta t time. Delta means change, and I'll show later in the video what it mathematically is equal to. Now let's draw a position time graph. So first we draw a coordinate plane. Y-axis shows the distance in meters and x-axis time in seconds. So the car from the example passed 10 meters in 1 second. So we find the point where 10 meters and 1 second intersects, 20 meters and 2 seconds intersects, because car covers 20 meters in 2 seconds. And the slope of the line is always equal to the velocity. And one way to find the slope of the linear line is by using tangent. If you need more detailed explanation of what tangent, sinus, and cosinus is, comment me below. So to find the velocity, we divide distance by time. Here what delta means: final position time or another measurement subtracted from the initial one. If you know the angle, you can easily find the velocity just by using tangent, but if you don't know, this is the second way. So to find the slope or gradient, we need to choose 2 points. Let it be here and at 0, because this way it would be easier to subtract. We can see that x2 is 20 and x1 is 0. Time 2 is 2 and time 1 is 0. So 20 divided by 2 is 10. This way we can find the velocity by using graph. Now let's draw velocity time graph. So y-axis is velocity and x-axis is always, practically always time. So the line will be straight because in our case the velocity is constant. And the area under the line is always equal to the displacement. This means that velocity multiplied by time is equal to the displacement. So the velocity is 10 in our case, and time is 5. 10 multiplied by 5 is 50, and 50 meters the car covered. Now we know of two formulas to find the distance. First one is by using the graph. Second is velocity and time multiplied. So this means they're equal to each other. Delta time means final time minus initial time. We take x1 to the other side, and it's the new formula to find the final position. Let's solve some exercise. The position of a track at the moment 0 is 250 meters. It moves with a constant velocity, and at 20 seconds, its position is 750 meters. We need to calculate the track's velocity by drawing its position time graph. Vertical line expresses position and horizontal line time. We know that track starts moving at 250 meters. And at 20 seconds, its position is already 750. This is a position time graph of the track. To calculate the velocity, we need to take covered distance and divide it by time. The first point is at time 0 and 250 meters, and the second point is 750 at time 20 seconds. So at second point, time is 20, and first point is 0. 750 minus 250 is 500. If we divide by 20, we will get 25. The answer for the first question is 25 meters per second. The velocity is. The second question asks to draw the velocity time graph. Let's highlight the previous answer to not get confused. We know that the velocity is constant, 25 meters per second, so the line will be straight. Next question. Find the position of the track at the moment, time 30 seconds. To find the position, let's use the velocity time graph. We know that the area under the line is equal to the distance covered by the object. So to find the area, we multiply 25 by 30 and we'll get 750, which is the distance. But it says that the track started moving at a certain position. So we need to add them, 250 and 750. We'll get 1000. This is the track's position at 30 seconds. Now I'll write all the answers to the left side to make space for other questions. The solutions you already know. Next question is D. Find the displacement of the track between 30 seconds and 60 seconds. So we will draw velocity time graph and find the area of that gap. Velocity is constant, so a straight line there is, and at 30 and 60 seconds. Now we need to find the area of that square. The width is 30 and the height or length is 25. 30 multiplied by 25 is 750. This is the value of displacement. The last question E. Write down an equation for the position of the track as a function of time. The question asks for a formula that can be used to find the position at any time. So this is the last formula that we learned. Initial position plus velocity and time. So just replace them with actual value. If we put any number in the place of the time, we'll get exact position of the track at that time.